In this video, we're going to cover how the building standards that we have included in this research address the embodied carbon reduction. Specifically, we're going to talk about the reduction of embodied carbon requirements for each of these standards, as well as the concept of resource efficiency, which can be as interesting when it comes to designing buildings that are energy efficient and have low carbon embodied in the materials used. So with the reduction of embodied carbon, there are different tools that can be used for each of these standards in order to reduce the embodied carbon for each project. But the reality is that at this time, none of the building standards that were included in the study actually have hard requirements to meet in order to reduce embodied carbon. So none of the 12 or so building standards that we have reviewed in this research currently have hard requirements in terms of embodied carbon reduction. Something that is very interesting is looking at the resource efficiency that we investigated for this research, and it's going to come up next. And by resource efficiency, we have a goal of comparing a prescriptive approach standard to a performance-based standard and see how they perform. And we selected projects where the resulting operational energy efficiency will be similar between the prescriptive and the performance-based standard. And then we looked into how we could use, how we can be more efficient in terms of resources, both in terms of cost as well as in material, because material, construction material, has cost associated with that. And that's not just money. Cost is also embodied carbon. So we looked at that too. The true building standards that we selected in this research for the resource efficiency comparison are PHI low energy building standard, that is a performance-based standard, and FUSE 2021 core prescriptive, and as the name says, it is a prescriptive approach. This is the bubble chart shows the site energy demand for heating and cooling for the 50 individual projects and how they compare using the 2018 baseline energy code, 2021 ICC, as well as the FUSE 2018, 2021, 2021 prescriptive, as well as PHI's low energy building and PHI passive house, as well as Pretty Good House. In the graph, the Pretty Good House that shows 0 is where the Pretty Good House was not applicable to those standards. In selecting projects that would fit the comparison for resource efficiency, it is shown in the graph on the right-hand side here, where we looked at projects modeled for the PHI low energy building standard as well as the FUSE prescriptive approach. We selected projects where the two, performance-based and prescriptive, would come within 20% plus or minus energy efficiency of one another. So in other words, we looked at a prescriptive approach and a performance-based approach that would yield similar energy performance, and we're going to compare how more or less efficient in terms of resources these standards are. So look at the resource efficiency. We looked at A, the prescriptive approach. In this case, we selected the 2021 FUSE prescriptive. And B, performance-based. In this case, it was the PHI low energy building standard. And we looked at projects of the 50 ones that we considered. A, we narrowed it down to the ones where the FUSE prescriptive approach was applicable. Please have a look at the video we did to cover the applicability of different building standards. And within these, we looked at which projects the 2021 FUSE prescriptive and the PHI low energy building standard would come within plus or minus 20% of each other in terms of site energy demand for heating and cooling. This is what it looks like, which assemblies were prescribed by Fuse and which assemblies were determined by means of the energy model, PHPP, for the buildings to meet the PHI low energy building standard. And on the right hand side, you see deltas of R values looking at which assembly and for which project Fuse required higher R value versus PHI low energy building was requiring higher R value. And based on this, we started looking at which building standards would get you to a similar plus or minus 20% site energy demand of one another with less stuff used, like less insulation, for example. So looking at resource efficiency, we found that 18 projects fit the criteria. So for 18 projects, the performance of the Fuse prescriptive and the PHI low energy building would come within 20% of one another. And then to get to the same performance, we found that the performance-based approach allowed to save a lot of stuff. Like in average, we found that you need over 800 cubic feet less of insulation to get to the same energy performance for a performance-based standard, because by means of the energy model, you actually know what you're doing. It's simple as that. With the use of the energy software, you know where you're getting the best payback for the insulation at your wall, your ceiling, and so forth. And some key parameters, including, for example, selecting the right coating for the glass, the solar heat gain coefficient, made a huge difference. And this is something that is extremely important to understand. The closer we get to zero energy consumption in buildings, the more all of these details matter. And this is where prescriptive approaches fail, because you just apply individual requirements to components of the building envelope, but you have no idea of how the building is actually performing. Whereas for the performance-based standards, by means of the energy model, you actually know what you're doing. It's literally as simple as that. So in average, we found that to get to the same energy performance, PHI low energy building required 830 cubic feet of insulation less. That's a truckload. That is thousands of dollars of less insulation to pay. And we cannot relate this directly to embodied carbon, but if you're needing 830 cubic feet less of stuff, your embodied carbon footprint is going to be less. Then we also looked at the cost of the energy modeling. And in this table, we listed what we charge our clients. Again, these are 50 projects from our modeling. And so we looked at how much we charge for each project. And in average, we found that even when you account for the cost of the energy model, performance-based approach would save over $5,000 overall, because you need a lot less insulation to get to the same performance. So this is not really about comparing PHI and Fuse. This is more about understanding that if you're using a prescriptive approach, you're going to end up over-insulating and overdoing certain things because you don't actually know what you're doing, because the prescriptive approach is something that really doesn't deal well with high performance. This is the average that we found, that in average, including our modeling fees, the savings per project were over $5,000 by pursuing the performance-based approach. So we come to the scoring for the embodied carbon reduction. We see the criteria that we have listed. Embodied carbon reduction goals, none of the standards that we have reviewed for this research have hard goals for embodied carbon reduction. So none of them scored any of those 10 points that we are allocated to that criteria. And then those building standards that do have a performance-based approach do get the remaining 10 points for the resource efficiency. In other words, the embodied carbon reduction was benchmarked against the 2018 energy code, but really none of the building standard that we reviewed provided any hard requirements for that. And then the resource efficiency we describe, whichever building standard requires a detailed energy analysis was allocated those points because it allows to meet the same energy performance by using fewer resources, both in terms of bulk insulation as well as cost overall. And this is what the allocation of points looks like for the embodied carbon. Basically, none of the standard received the full 20 points because none of the standards have actual hard requirements for embodied carbon reduction, but the standards that have a performance-based approach then do get some points because they allow that flexibility that prescriptive approaches don't.